The most dangerous phrase a architect can hear is a direct request for a specific solution. The junior data engineer or architect starts coming up with a solution immediately. The senior architect knows that his job has just begun. Today, we're talking about a single skill set that separates good engineers and architects from great ones. It's the single most important thing that I've learned in my career. It's asking the right question. After more than 20 years of working and leading data teams, I've seen more projects go off rails because of misunderstood requirements than any given technical challenge. As the saying goes, the technology is easy, right? In this video, I'm going to give you a framework to move beyond being a solver of stated problems to becoming a real discoverer of business needs. This is the key to true technical leadership. Business users will often tell you they want the data to be available in real time or immediately. Instead of just blindly coding away, ask them what they want the data to be, what they want to use the data for. They oftentimes want the data to be available when they want to look at it and don't understand the implications of presenting real-time data. Real-time data has a place, and and sometimes you can offset the cost involved in it by the benefit you can gain from it. But for the most part, you have to start with asking the why. This is saying that a good answer solves today's stated problem. A good question solves tomorrow's real problem. With that in mind, let's have a look at the value of a good question. First of all, a good question reduces your business risk. Think of the missed opportunity cost when you bark up the wrong tree by trying to invent a solution to a problem that doesn't exist. A good question increases your stakeholder alignment or creates stakeholder alignment. I've seen so many instances where a tech team goes off and invents a solution without understanding what the stakeholders actually asked for in the first place. Thirdly, a good question can help you future-proof your architecture. Think about asking questions about scalability, maintenance, and those kind of aspects of a problem or a solution, and consider how valuable a good question is in that context. Finally, a good question builds authority. If you ask the right question, then people will trust you to come up with a better solution than somebody who makes blind assumptions and starts inventing solutions to problems that don't exist. To make matters more concrete, let's have a look at the CARE framework or mental model. We start with context, or C for context. Questions about the why. Why are we doing this? What business value is there? Why how urgent is it, for example? Next, we look at assumptions, the hidden risks. What are we assuming about the user's behavior, and what other assumptions are we making in order to get started with the product? Thirdly, we look at risks and restraints. What are the non-functional requirements? We already spoke about the latency and acceptable latency levels, in addition to the security and those kind of non-functional aspects of the system. In addition, we need to look at the cost of the system. What is the budget or allocated budget for the system? Finally, we look at the evolution. We look at the evolution or future of the system. How does the system need to respond in, say, 2 or 3 years from now, and what are we going to do in the face of changing requirements to the system? Here's a little app that I wrote with the help of Gemini to evaluate requirements against the CARE framework. We start by providing a quality prompt. I use Gemini again to reframe my original prompt in order to avoid garbage in, garbage out. If we look at the context, you can see we're asking questions about what business outcome are we driving with this app, how urgent is it, and what are the success metrics. Let's look at the assumptions. We're mainly making assumptions around the quality and the accessibility of the data sources. So we can see that one of the risks is that the data source might, for example, provide batch updates and we're looking for streaming data. Another risk might be that the data is not consistent and that there's delays in the data. Here are some assumptions that we're making. Firstly, we're assuming the data is accurate. Secondly, we're looking at capacity planning and is the data, do we have enough capacity as far as uh, the BigQuery provisioning and those things go. And then lastly, we're making assumptions about the transformations needed to provide the user with this kind of report. Look at the assumptions and notice how these things are normally implicit. If we make it explicit and ask questions about these assumptions, we'll be in a much better place. Here's the risks and mitigations. Firstly, the app provided us with a recommended architecture to implement in order to mitigate our risks. And then we look at the risks themselves. Normally, security and access control is a key risk and needs to be mitigated by robust IAM policies. That then we look at the data pipeline failure and monitoring. What How are we going to know if the data pipeline fails and how are we going to troubleshoot it? And then the third risk is the scalability or performance of BigQuery if not properly used. So we need to make sure that we understand the way in which to use BigQuery properly and according to their best practices to get the best performance out of it. So let's recap what we learned. It's more important oftentimes to ask questions than just to come up with solutions. Use a framework like CARE to guide your inquiry into questions and understand that part of your job is to de-risk the solution as opposed to building solutions just randomly without properly understanding the requirements. That's it for me from this week. Don't forget to like and subscribe, and I'd like to hear from you now. Which questions have you asked that helped you save a project from all but certain doom? See you next time.